So thank you all for being here, even after nap time. So when Bergman and Sams proposed their model for the flipped classroom in 2007, they were really riding a wave that had started all the way back more than 10 years before with Alison King when she published her seminal paper entitled From Sage on the Stage to Guide on the Side. But what they did was to combine for the first time two elements that were separated before. One was the notion of peer instruction that was proposed by Eric Mazieu in 1997. And on the other side, the concept of using educational technology, such as videos, as it was introduced by Salman Khan, the Khan Academy person, in 2004. And so a lot of the effort that has been dedicated to developing flipped learning has been trying to follow these guidelines, trying to improve students' experience of the classroom, following objectives that have not changed since 1993. So the idea that Alison King and all the other people who have participated in the development of a flipped classroom over the years, all these people have all tried to follow the same kind of objectives, which is to try to maximize what teachers can do during the class time. And so this was coming from the idea that the class time is the one time where students can really interact with each other and with their teacher and try to receive timely feedback and support. The idea behind a flipped framework of education is not really about the technology. It's more about what teachers actually do in class and how they interact with their students. To cite someone who implemented the flipped pattern in Michigan, Bruce Umstead, said it's not about technology, it's about changing instructional models so students can receive more instructional support in the classroom. And so in this presentation today, I will not so much focus on the technical aspect of flipping the classroom through videos, through other kind of digital media. I will try to focus more on the practical approach to class activities done in class in order to increase motivation, in order to increase engagement in students. And so what I have done since a few years ago is really to follow the pattern of the flipped classroom as it was developed. So traditionally, the lecturing happens in the classroom. Information is given to the students. The students take this knowledge at home and apply this knowledge solving problems, etc. The flipped pattern is inversing the point of reception of information and allowing students to go at their own pace and repeating sometimes the acquisition of information several times in order to get the knowledge, the basic knowledge about the topic before coming to class. And so this frees up time for class discussion, class activities that expand a bit the knowledge obtained in the videos. So this combination of the use of technology at home and the support obtained in class changes dramatically the learning environment for the students. But not only what is given to the student is different, it's also a question of what they do themselves and how they are involved in the classroom. So that's why I prefer to use the term learning ecosystem rather than talking about learning environment, in the sense that the students are producing interactions that themselves modify the way they obtain the information and construct their own knowledge. So through this presentation, I will try to introduce you to some aspect of flipped learning applied to different types of classrooms and the different steps I use to organize my activities and try to maximize engagement in students in the class time. So usually my my motto when I design activities is basically the same as recycling. I'm trying to reduce the lecturing as much as I can, try to focus it on really core concepts. So these are the materials that I produce for the videos, through readings, and through other materials that the students acquire at home before coming to class. I try to design, like has been shown before, quick quizzes, quick application exercises so that the students reuse the concept that they have obtained in the videos so that they can check that they have learned the concept. But what I do in class is more an expansion aspect. So I'm not really repeating the same thing again in class and trying to repeat the same thing in class. I'm really trying to recycle the knowledge and try to apply it for different purposes in different contexts. And so at this point, I would like to make a separation between what for me was two different types of classes. I've been teaching science writing and humanities writing to Japanese students in their first year here. And the type of activities that we do in class is very different from the type of activities I would do in a more content-based class. So I would distinguish, for example, the knowledge-based classes that are heavily relying on the acquisition of information, so understanding mathematical theorems, knowledge about biology, etc. And so these are really targeting the acquisition of ideas and concepts. In a skill-based class, it's more a question of understanding a process, understanding how the students can actually combine things together in order to produce something. And so these are more in the category of skill that they need to acquire through the video and then apply in class. And so because there are different types of classes, the type of activities that are designed should also be different in order to approach the different type of contents. And so that's why they require different type of activities in order to provide a different kind of experience for each student. And the teacher focus is therefore also different. So for a knowledge-based class, the teacher is supposed to help the student through continuous feedback, questioning, etc., in order to help students assess what they know and what they don't know. When they can understand clearly what they don't know, then they can themselves tailor a bit their learning process to palliate what they don't know. For a skill-based class, it's more a question of practice. So the teacher's focus is more into creating a framework in which the student will have opportunity to practice again or in a modified way the skills that they have acquired through the materials initially. And then receiving feedback from peers and from the teacher about how they are producing their work. So to give you some examples, for the same kind of flipped pattern in a biology class, for example, if I'm doing a short skit video about photosynthesis, what I would try to give as information inside this short video would be the general concept about photosynthesis, how it works, how light is being received by the plant. And so at one point in the video, I would introduce maybe a short quiz with a question that is specifically targeting information from the video. So what is the function of a cytochrome P450? And so in that case, the student can directly evaluate if they got the information or not. In the classroom, then I'm doing something that is different. I'm not exactly repeating the same information. And I'm using other techniques, such as, for example, here peer instruction, as proposed by Mazur. And I'm asking a question that invites students to discuss and try to solve a problem together. So what would happen if we added sugar to the soil near the roots of a tree? If the student understood the lesson about photosynthesis, they will understand that it doesn't matter where you put the sugar at the roots of a tree is using the carbon from the atmosphere. So it doesn't change anything. So through discussion, usually I'm using clickers at that point for peer instruction. So I'm giving the question, students are answering me. If I notice that there is a chunk of the students who don't get the information and let them discuss, usually they all migrate to the correct answer. So that's an example for biology, but it's not restricted to the sciences. I can do the same kind of pattern for a history class, for example. If I'm giving information about the French Revolution, I can give the name of the main players, give information about when they were active, what they did. And so I can insert some specific question about the content of the video. In class, we can have more discussion about the idea of the French Revolution, expanding about what it was, how impactful it was. And here, instead of having a peer instruction question, I can invite more of a debate. For example, here with the question, is political violence justifiable for long-lasting political change? So the common point between these two different classes is that they rely heavily on the acquisition of information. So students receive information through the content of the online material, and then they use it in class. In the case of ALES, the scientific writing class, or ALESA, the humanities writing class, the process is a bit different. If my video is talking about how to make a paragraph, okay, I can, of course, give a quiz question about what is the name of the first sentence in the paragraph. It's a topical sentence. But even if they know what a topical sentence is, that doesn't mean that they know how to write it. And so the class time is therefore not specially inviting students to reflect on what is a topic question, but more about how to write it. And so the class time is more inviting activities such as peer reviews, where students are producing examples of topic sentences, exchange, receive peer feedback, or feedback from the teacher. So this was to illustrate how flipped patterns can be applied to different sorts of classes. So even though knowledge-based classes and skill-based classes invite different type of activities, they try to target the same kind of engagement or motivational techniques. And so that's what I'm going to talk a bit about now. So just to give you some context, I'm coming from a biology and earth sciences background. So in France, I passed a national license to teach at junior high and high school called the CAPES. And so afterwards, I decided to specialize and do my PhD in paleontology. I came to Japan with the Mombuka Gakusho scholarship. And after finishing my PhD, I did 1 year of postdoc and started working at ALES in 2011. With Steve Kirk, we started to think about flipping the classroom in ALES because we had to juggle with two major difficulties, which was to teach students who enter the university about science and teaching them also a bit about how to write. And so the two things were very heavy in terms of time that was being consumed. And so we decided that flipping was maybe the way to go to kind of focus more on the application exercises in class. Recently, so since maybe a year now, I've been developing also materials for ALESA. And I've also been working a bit with the people from PIC, so the program in English at Komaba, teaching some paleontology classes. And so all these classes are classes for which I have developed a flipped pattern. And today I will talk to you a bit about some examples, specifically about the application of flipped patterns inside these classrooms. So this is an example for a skill-based class, ALES, so scientific writing. And so the goal of the program is to show students how scientific writing is conducted by looking at several examples from the literature and trying to work on exercises. And to provide them with the context in which they learn, we require the student to conduct themselves a scientific experiment and write a paper about it. And so the final product of the course is this report, scientific report that the students have to write. We follow an IMRAD format for introduction, method, result, and discussion. And so we treat all the sections of the report in various orders, but we all treat the same sections. So for example, if I'm considering a lesson about the introduction section of a scientific report, I'm providing students with a set of videos that are dealing with the content and the craft of writing the introduction. I'm using a platform called Scalable Learning that has been developed in Sweden. And Scalable Learning is a platform that links YouTube videos into this online interface. So students can access, after registering to Scalable Learning, they can access the videos. Quizzes are integrated to the videos, and they can be of different forms and shape. So after this homework has been completed, students can come to class. So the first part of the class is mostly the reusing stage of my flipped pattern. So I'm asking questions to really check that the student got the information. And then afterwards, it's more the development phase. So because we're talking about the introduction section, we do a sort of simulation, an exercise. So they work in small teams, 4, maximum 5 students. And they all work on the same project, so writing an introduction for research about the effect of music on gorillas. And each team has to produce an introduction that they write on the board. At the end of the activity, the goal is to look at all these introductions, look at the similar points and differences, try to see what's good, what's bad, and that way they can discuss and try to arrange at the end their own product. The last part of the class is more dedicated to their personal research. So they have their personal research project, and so they can start the writing of their own introduction. At the same time, they can discuss with their peers. They can collaborate on the writing or try to see what they need to improve by asking to the teacher. So this is the kind of pattern for one class. What I thought was important in the ALES context was that the activities done in class need to be realistic. They need to provide a sense of realism to the student in the sense that the activities are not decoupled from the final research that they do or the goal of the class. Giving them simple writing exercises about finding the missing word or trying to find the grammatical mistake is not really the object here. And so my job in the ALES class is to provide basically this framework where students are basically suspending their disbelief about the course and trying to agree to engage with materials as if they were scientists writing a paper. And so I'm kind of a director in this kind of sense, but I propose material and I'm giving them the story, but they are doing most of the heavy lifting and doing the activity. So this leads to a dramatic change in the teacher and student's role in the classroom. So students can become self-learners. They're more responsible about their learning. Even if the teaching is not such good quality. Okay, so for example, if we take the example of video games, people who don't know about the video games, if they are invested in it, if they want to play it, they will try to find resources, YouTube videos, looking at web pages to find the information in order to do it better. And so if the materials are engaging, if the students are provided with a context that is realistic and motivating, they can be very efficient, safe learners. In our classes in ALES, we are often asking them to work in teams. So this also increases the sense of responsibility towards the learning. They have a final goal that they know how to achieve, and so they know how to evaluate what is good, what is bad, through peer review and through discussion with the teacher. And the final role that the students take in class is the role of instructors. So they are in charge of doing a piece of the research, they collect data, they share it with their peers, and doing that, they obtain a piece of information that the other members of the team don't have. So this kind of activities done in the LS class is really reinforcing the collaboration between the students. And because students are doing so much work, the teacher also changes a bit its focus. I'm mostly doing design for the activities, so trying to find out what would be best to really make the student engaged. I'm trying to under-define the activities as much as I can. So that means I let the student try to understand what the rules are and try to understand how to solve the problem rather than giving complete directives. And so I'm more of a facilitator rather than a leader in the activity. I'm giving guidance to really enable the student, but I'm not really telling them what to do and how to do it. And finally, I'm acting a bit as a coach in the sense that I'm showing the student as much as I can how to do things. So working on the same raw material, trying to write together in real time, in class time. So that was about the activities and the type of activities that I'm using in ALES. To give another example, using a type of activity in a paleontology class. If I have a lesson about uniformitarianism, I would use the same platform, provide a short video about the concept, try to illustrate what it means, what are the limitations of the definition, etc. And when the students are coming to class, I'm using a lot of peer instruction techniques to assess whether or not the knowledge has been acquired. But then the activities that are described here are aiming more at expanding the knowledge, trying to understand what works and what doesn't work with this scientific concept. So uniformitarianism is a notion that things are always the same. Okay? So if we understand how the present works, we understand how the past works or worked. So here we're talking about Lamarckism and the giraffe's neck, etc. And then afterwards we work on real data, trying to understand how we can use uniformitarianism and, well, critically using it to be able to reconstruct sea level changes in the Caribbean. So this is an example of authentic activities used in the science context. So in either way, either in ALES or in a science class, engaging the student requires the activities to have real-world significance. They need to be relevant. So if the student thinks that there is a complete gap between what they do in class and what they will be expected to do in the future, either for their final product for the class or for the rest of their studies, then it's not good. It's important that the activities are explained just enough that they understand the concept of the activity, but not enough that they would just follow a set of guidelines and answer yes, no every time. The activities should be organized in a collaborative way, so that means that as much as possible, not letting one student do all the job while the others are freeloading. Each activity should be assessed and accompanied with feedback. So just doing an activity and then saying, okay, you've done it, now we can move to another point, is not good as well. And finally, what I think is the most difficult aspect of making activities is that each activity should have a value in itself. So that the student don't see the activity that we have done in ALES, for example, about writing the introduction, about something that has only the use of being transferable to their report. They need to be understanding that what we have done is a process that they can actually transfer to many different things, not only the context of writing the report in class. So the activity should have a value in itself and not only as a preparation for something else. So after we have started using a flipped pattern in ALES, we tried to get student feedback. And so that's a research that Steve Kirk and I have conducted over 1 or 2 years. And we have published this data recently. So what you see here is the answers from first students, 121 of them, to the question, have you watched the videos? Most of them say yes. In this case, when we saw that many students were watching the video, we then wondered if it was easy for them to understand them or not. And so when we asked them were the videos difficult, most of them said that it was not really difficult to understand. Most of our videos are within 10 minutes long. They are quite short. And each of them is kind of a module element. So for example, if we talk about the method videos, there are 2 of them. One is about what kind of ideas are in the method, and then afterwards, how to write it. So students found that the videos were not too difficult. But then afterwards, when we asked them, was it useful for you personally, many students said that the videos were useful, but not the activities. So we faced here a problem, because most of the activities, well, still had some high level of satisfaction, but it was way less than what we expected from the videos. And so we decided at that point that not only providing videos, but really rethinking the activities in class and trying to really make the materials more engaging was something that we had to do. So this is to illustrate that flipping the classroom is not a question of just putting videos as homework and expect the class to just happen by itself during the class time. It's really a lot of work to really reformat the classroom time. So the main difficulties for that are that students sometimes face difficulty to move from the classic high school framework where they are given the information and in a very exam-oriented way and transition to the university kind of process. And so the teacher is required to help and ease this transition. When designing activities, it's important that the teaching style is connected to the learning style of the students. So if students are more visual oriented, they retain information better through visuals, and the videos are good, but then it should not be a boring set of pointers on a blank slide. And then the difficulty is then finally the time and the resources. It takes a lot of time to produce, it takes a lot of effort, and so some teachers are thinking that maybe it's not for them. But on the long term, it's an investment that actually pays off importantly. So to conclude, this idea of flipping the classroom is pretty much adaptable to any kind of classroom that you're looking at, skill-based or knowledge-based. But in any case, it requires from the teacher a lot of effort to try to rethink the type of activities that are done in class in order to really fulfill the objectives of a flipped classroom pattern. Thank you very much.